Hello everyone. Today I'm going to show and teach you how to configure your router. So, first of all, you need to know what is your default IP address. So, your default IP address depends on what internet you are using. So, if you're using if you don't know your default IP address, you can basically just search it for the internet. So in my case, my internet is Converge. So this is my default IP address, 192.168.1.1. Just enter it there. After entering it there, it will bring you into this one. So as you can see, you have a username and password. So if you don't know the default for this one, because this one also based the default username and password also based on what is the model of your router. So if you don't know about it, you can check it under your router. So in my case, my default username is user, then default password is user1234. Then after entering that, it will bring you here. So as you can see here, you can check the status of your router, your device information, your LAN status, and anything else. Here your wireless status, 5G wireless status, Wi-Fi client list, and in the network, here you can change your SSID or the name of your internet, and also the password of your wireless connection. So it depends on you if you want to change yours. I'm just showing you how to change it. So you can just change it there, and in the management, the one you used to enter earlier, you can also change the password of it. And here in device management, if you want to reboot your router, you can also do it here. So basically, that's all for this video, everyone. I hope you learned something. Thank you for watching. So, hello everyone. Today I'm going to teach you how to answer or to do custom subnetting and subnetting process. So here we have a problem and also a given. As you can see, number of needed subnets given is 1000 and number of needed usable hosts is 60. So as you can see here, we have our IP address or network address. So the given is 165.100.0.0. So basically, with this given, we can already tell that our IP address is class B. So since we have a class B network address or IP address, automatically we have two hosts already. These two zeros in the end. So basically, all we need to do is simply convert the two hosts into 8 bits each. So here we already converted our hosts into 16 bits in total, but 8 bits each per 0. So now we're going to write the decimal value. So we're going to make it something like, let's say, blue. So the decimal value is here: 1, 2, 4, 8, 16, 32, 64, and 128. And here we repeat from 1, 2, 4, 8, 16, 32, 64, and 128. So if you're asking why do we only have 8 bits and why do we need to only stop at 128, simply because the limit of our IP address is only 255. So when we add this all, we have a total of 255. So next, as you can see, we are asked, since we are asked for the total number of subnets here in our problem, we're going to write the subnet above the decimal value, which is starting from left side to right side. And we also need to start at 2. Now again, we're going to start from left to right, starting with 2. Now we have 2, 4, 8, 16, 32, 64, 128, 256, and here we need to continue. So 256 plus 256 is 512. Wait, let's double check. Yes, 512. Now 1024, 2048, 2048 times 2, 4096, shit, times 8192, 16,000, 384, and we times to that again. So as you can see, it is really a long process, but it is not that hard. It just takes time to learn this. 3768 times to that again, 6556, 65536. So as you can see here, we already have our subnet. Let's change it into color red, maybe, so you won't get confused. Now the next step, you will be needing to write the host part, or the host address. So what we will do is, we're going to start from right to left this time, and same as before, just we need to start at 2. So we just copy this one, 16, 32, 64, 128, 256, 512, 1024, 2048, 2048, 4096, 8192, 1638, 4, 32768, and last is 65536. Just stretch it a bit. As you can see, it doesn't fit. Let's make this smaller, I think. Maybe 10 or 8. There you go. Let's make it color yellow. Color yellow. Oh, orange instead. Now there, we already have this one. So, wait. Let's try to remove. A, E, O, U. Where's the shading go? There, we have the border. Now proceeding. Now we have our needed subnets, which is 1000. So as you can see in our subnet, we don't have 1000. So what we need to do is we find the nearest one, the nearest number after 1000. So in our given subnets, we have 1024. So that will be the total number of subnets we have. Okay, so all we need to do is insert a line. So wait, so that you won't get confused. There we go. So since we have already gone through this far, we can answer some of the question here below. So like what I've said earlier, the IP address given was class B. So since our default subnet, so since it is class B, our default subnet mask is 255.255.0.0. So since we have our line here, so that indicates that we need to stop here. So to identify the custom subnet mask, as you can see, we have our first octet here. So basically we cannot combine both octets. Okay, so as you can see, we have completely 8 here. So our third octet will be 255, because if we add this all together, the answer will be 255. So we put it 255.255.255. Now in our fourth octet, we can see we have 2 zeros here, since there is a line, so we need to stop here. So we just simply add this one. 128 plus 64 is 192. There, we have our custom subnet mask. Now going back to the given, as you can see, total number of subnets that we have is 1024. It's right here, 1024. And the total number of house address will be 64, since in the given, number of needed usable hosts is 60. Since we don't have 64 is the nearest number. So since we don't have 64 is the nearest number. So as you can see, right here, 64. So how we're going to answer this? Simply, we just need to minus 2 here, our subnets and our host address. So 64 minus 2 is 62, and 1024 minus 2 is 1022. So if you're wondering why do we need to minus 2, simply because the first and last value is invalid. So we're going to subtract it always into 2. Now next, number of bits borrowed. So as you can see here, we have our line, and we have 1, 2, 3, 4, 5, 6, 7, 8 bits for our third octet, and 2. So 8 plus 2, we have 10 bits borrowed. Now proceeding to the next questions, they are asking this following questions. So after this, we have something to do a little bit difficult and also a long process, because we need to do a pattern. Okay, need to insert one more, insert below, insert below. Okay, let's just put some border first. So for you won't get confused, all borders. Okay, now here we have a pattern here, which is 0 and 1, 1, 0, 0, 1, 10, and 11. There. We're going to do this pattern for us. So going back. So the reason why we need this pattern again, so that we can answer some of the following question right here below. So since they are asking what is the 15th subnet range, we need to make until maybe 15 of this pattern. 15. So as you can see, we already have 1, 2, 3, 4, 4 patterns made. So the pattern goes like this. We just need to remember that we need to start from 0, 1, and stop from 11. So since we already have 11, so since we already stopped at 11 or the tenths, we need to proceed to hundreds. So we're going to make that 1, 0, 0. Next unit, it will be 1, 0, 1. The next it will be 1, 1, 1. So we've already reached 11 again. The next pattern will be 1, 0, 0, 0. And it just keeps on continuing. There. It continues. We're going to make it 1, 0, 0, 1. Then we're going to add another row again. 1, 0, 1, 0. Insert row again until it comes 1, 0, 1, 1. So since this pattern will take so long, we need at least 15 of it. I'm going to skip and be right back when the pattern is already done. And now we're back. As you can see, earlier I've made a mistake and forgot to put this pattern after this one. So I've double checked my pattern. Now we have at least 16 of it until 16. Here you can see. So the next step, if you're wondering what we're going to put in this side, simply we just need to put the IP address. We need to convert what we've done here. So simply we need to, since we have nothing, we need to write 165.100.0.0 since we have no ones to convert into decimal. So next, we need to write 165.100.0 since we don't have here in our third octet, and since we have 1 here, we convert it to 64. Next, 165.100.0.128, since we have 1 here in 128. Now next we have 165.100.0, since we don't have something here in our third octet, and since we have two ones in our fourth octet, 128 and 64, we need to add them, so 192, until we just continue until we get at the bottom. So we are back. So as you can see, I've finished writing everything. Now the next thing we need to do is to write the IP address before the next IP address. So since it is 64, need to write 165.100.0.63. We do the same until the end. Since it stopped at 128, we will going to write 165.100.0.127. Do the same process until you reach the end. So I'm be right back, guys. Now since we were able to complete this pattern, we can finally answer some of these questions. So what is the 15th subnet range? So if we're going to look here in our 15th subnet range, the answer would be this one. There. As you can see, we have 165.100.3.128 to 165.100.3.191. So here, the next question, what is the subnet number for the 6th subnet? So by the way, I forgot to tell you that this first one, we call this the subnets, and the second one is the broadcast. Where is that? The broadcast address. So since in this question number 10 they're only asking for subnet, so we're going to look for it. 1, 2, 3, 4, 5, 6. So our 6th subnet is here, 165.100.1.64, and here they're asking for the subnet broadcast address for the 6th subnet. So we're going to look for it. 1, 2, 3, 4, 5, 6, and the broadcast address. Here we have 165.100.1.127. So for the last question, what are the assignable address for the 9th subnet? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, here copy this one. So as you can see, what we said earlier, the first value and the last value is invalid, or we cannot include it. So as you can see, this is our first value, and this is our the first value. This is the first value, and this is the last value. So if we're going to look at it, the number in between them, here, the next one will be 165.100.2.1, right? That is the second to the first value. And the last one before the last value is 165.10.2.62. So since the first and last value is invalid, we're not going to include them in the assignable address. We're going to use this one instead. And now we're done answering, or we're done doing the subnetting and custom subnetting process. So there we go. Thank you for listening and for watching this video. I hope you understand anything from this tutorial. So hello everyone, today I'm going to show you some of the basics here in Cisco. So what is a Cisco Packet Tracer? So basically Cisco is an application where you can do some computer networking. So as you can see here, we have a plain white sheet that looks like an MS Paint, and here on our bottom left you can see some devices like routers, switches, hubs, wireless device, connections and devices, security, WAN emulation, custom made devices, and multi-user connection. So I'm going to show you here in end devices. So let's say you have a computer there and computer here. So I'm going to show you some of the basics here. Okay, so let's say you have both of your PC here. You have two computers, so let's say we want to connect them to each other. So we're going to use crossover cable. There. Now you can see it's simply connected to each other, right? So if you click our computer here, you can see how it looks like. Your system unit looks like. And then we go here to desktop, you can see some of its part like IP configuration and other else. So let's try putting an IP address in this computer. Let's say I want to make it 10.10.10.1. And then in our other computer, let's make it 10.10.10.2. Now since they have already their own IP address, let's try sending a file if it's going to work. So since you're in real time, let's try to go to simulation right there and just click this autoplay. Let's see if it is working. And there, as you can see, it is working, guys. So simply here in Cisco you can explore many other things like trying to put routers or other like switch, but for today I'm just going to show you the basic like this one. So thank you for watching, guys. So hi guys, today I'm going to teach you how to make three different types of cables, which are the straight through, crossover, and rollover cable. Okay, first of all, we're going to need a UTP cable, and then a wire stripper, and a crimping tool, and also a LAN tester, or what they call cable tester, and some RJ45s. Okay, now we're going to make a straight through cable with using this UTP cable. So first, all you need to do is to strip at least 1 inch from this wire, then simply strip this. There you go. So as you can see, there are wires inside with different cable, different color. So in doing a straight through cable, we need to follow a certain color code, which is the white orange, and then orange, then white green blue, then white blue green, and white brown brown. So we just follow that color code, we aligned it. Again, it's white orange, white orange orange, white green green. Oh, white orange orange, white green blue, and then white blue green, white brown brown. And then blue, white blue blue, then green, so there, as you can see, we have the color codes in order. Then all we need to do is to straighten up these wires, and then we simply use our crimping tool to straighten the wires. as you can see. Then we surely make the patterns correct. White, orange, orange, white, green, blue. After making the correct pattern, we put it in our RJ45. Then after that, we use our crimping tool to there we have our first side, or I mean the first point, and then let's do it in the other side. There's you can see. White, orange, orange, then white, green, then blue. First of the end. Blue, then white, then green, white, brown, brown. Then something to again. Release our crimping tool. So there, as you can see, we finish our both ends, and now we're going to try to test it if it is working. So when you're going to test a straight through cable, the outcome should be the same. Like here, I'll show you, like it's 1 1 2 2. See, it's working, right? The light is going the same way. So that's it for our straight through cable. Thank you for watching. So next, we're going to do the crossover cable. So basically, when we're going to do a crossover cable, we're using it for directly connecting a computer to a computer. So same process, you strip the wire. So basically, a crossover cable has a different pattern for each sides. I mean for both ends. They're not the same as to the straight through. They have the same color code in both ends. So here in a crossover, the first end will be white orange, then orange, then white green, then blue.
So this is our color pattern or code for the first end. So let's check it again. White, orange, orange, white, green, blue, white, blue, green, white, brown, brown. So we're going to cut this again. So there. White, orange, orange, white, green, blue, white, blue, green, white, brown, brown. So this will be the pattern for our crossover. We put it RRD45. White, orange, orange, white, green, blue, white, blue, green. Then we use our crimping tool to tighten it. Now let's proceed to the other end. Now in the other end, the pattern goes like white, green, green, white, orange, white, brown, brown, then orange, it takes patience in doing this. Now the pattern goes like white, green, green, then white, orange, then white, brown, and then brown, then orange, blue, white, blue. So here's our pattern for the other end of a crossover. So we just straighten it, and we cut it using our crimping tool. Then there you go. Now you double check if the pattern is correct. White, green, green, white, orange, white, brown, brown, orange, blue, white, blue. It seems correct. Now take your RJ45 and carefully insert this one. Make sure that the pattern is correct. Wait a minute. There you go. Then use your crimping tool to tighten it. Now we're going to test if it is working. So when testing a crossover cable, the outcome should come like they are in the opposite direction, not same as the straight two. Now as you can see, it is working. So that's it for our crossover cable. Thank you for watching. So now proceeding to our last and final cable, which is the rollover cable. So basically, a rollover cable has a different color code also. We commonly use this rollover cable to a device console port to make programming changes to the device. So the cables which are I think commonly used are the straight through cable and also the crossover cable. Now Our rollover cable has also a different color pattern in both ends. So in the first end, this white, orange, orange, white, orange, orange, then white, green, blue. White, green, blue. Smart, bro. The next, wait, let's do it again. White, orange, orange, white, green, blue, then white, blue, green, white, blue, green, white, brown, brown, white, brown, brown. There we go. Now we need to cut the end to straighten, to make a straight, and there. Wait. Let's double here. Let's double check. White, orange, orange, white, green, blue, white, blue, green, white, brown, brown. Now take your RJ45, simply plug it inside. Make sure the pattern is correct. Seems correct. Then use your crimping tool. And there you go. On the other end, a different pattern, which is brown, white, brown, green, white, blue, blue, white, green, orange, white, orange. So we're going to start with brown on the other end. So there, start with brown, white, brown, then we go with green, or white, brown, green, then white, blue. So as you can see, not every time we have the same color pattern. Then go white, green, then orange, white, orange. This straight, this up, then we use our crimping tool to cut the ends so that it will be aligned. There you go. Now double check the pattern. White, brown, then green. After green, white, blue, blue, white, green, orange, white, orange. White, blue, blue. Then simply insert it to your RJ45 carefully. Make sure that the pattern is correct. Brown, white, brown, green, white, blue, blue, white, orange. White, green. Seems good. And use our crimping tool. There we go. So that's it for our rollover cable. Thank you so much for watching. So hello everyone, on our last video we learned how to attach our UTP cable onto our modular box. So in this video we're going to try, or we're going to learn how to attach the other end onto our patch panel. Okay, so now we have our UTP cable here, and we also have our patch panel here. So all we need to do is to strip this UTP cable so that we can start. So there, as you can see, so let me cut first this annoying wire right here, because you're not going to use that. So now you have here our wires with colors. All we need to do is to arrange them first, because in attaching the UTP cable in our patch panel, we're going to follow a certain color code too. So in attaching this one, so as you can see, this patch panel has 6 ports. So the color pattern we need to follow is this one. As you can see, this brown. Since we are going to use T568B, we're going to follow that color pattern, which is brown, white, brown, then green, white, green, then orange, white, orange, then blue, white, blue. So good. So this is looking good, huh? So we're going to attach it. Here. First is the brown, white, brown, then green, white, green, then orange, white, orange, then blue, white, blue. Now we're going to use our patching tool again. I mean alternative patching tool, since in my case I don't have the actual patching tool. So we're going to simply patch it here inside.
So as you can see, we have our excess wires here. You can cut this excess wire with the actual patching tool because it has a patching tool that can cut the excess wires. But in my case, since I don't have the actual patching tool, I might use other way to cut these excess wires. But for now, I'm going to leave it like that, just to be safe. So as you can see, here we have connected our UTP cable onto our patch panel. So thank you guys for watching. So hello guys, today I'm going to show you how to attach your UTP cable onto this modular box. Okay, so first all you need to do is to open your modular box. There, as you can see. So in your modular box, you will see the color pattern that you need to follow when attaching the UTP cable. So here you will see that T568B and T568A. So what we're going to use is the T568B. So as you can see, the color patterns are white, orange, white, blue, and on the other side is white, brown, white, green, and green. You just need to follow these color patterns right here in the B sides. So now what we're going to do is we're going to strip our UTP cable so that we can attach it already. There we have our UTP cable. We just need to spread it out. So there, as you can see, we already have our different color patterns in color wires. So you need to follow color pattern on the first side, which is white, orange, and then orange, and white, blue. There. So this on the other side, white, brown, then brown, green, then green. So this will be the color pattern on the other side. As you can see. So now we'll carefully attach it here. With white, orange, with orange, and white, blue, and blue. So in putting the wires inside, we're going to need a patch, what we call patch tool. So in my case, I don't have the actual patch tool, but you can use the point of this wire stripper in patching them. So let's try putting the wire to its coordinate color pattern. The other side, on the other side, we have ah, white, brown, then brown, so we can try punching them. So I suggest not to use too much for still punching them. No? It's all good until you hear it clicks in. Oh, no, white green. Then the green. So there, as you can see, we've already attached it to the both sides. So now we're going to close it with our box. And this is how it looks like. So thank you guys for watching.